Okay, 6-4. We're making our way through 6-4. Today what we are going to do is we are going to learn linear speed and angular speed, and arc length, which is referring to the distance traveled. So we're going to cover 3 slides. The first slide is where I'm teaching you the formula, explaining it, and then the next 2 slides are where we are practicing it. The book only gives 2 practice problems, but because this is something that you're so unfamiliar with, I put 4 additional practice problems in there just to really make sure that you do understand how to do it. So the bad news is we're going to do something you're probably not going to like, and you're probably going to say, when am I ever going to use this? You're going to use it on the end of Chapter 6 exam, and you might use it on the final exam. That's it. The good news is I'm going to show you how to pull the key information out, and then it's the same way every time, like to set it up and solve. So that's the good news. It's the same every time. It's just a matter of reading it and knowing what number goes where. That's the trick. So let's go to this slide here. This is the slide you need to be on. All right, the title of the slide says Arc Length and Central Angles. Arc length may sound familiar. If you go back to geometry, you actually learned how to find arc length. You found it in terms of the circumference. So the circumference was the distance all the way around. The easiest thing to understand here is pizza crust. Right? The crust is around the edge. Okay, so the circumference of the pizza would be how much crust do I need for the entire pizza? And then in geometry, you learned arc length, because sometimes we don't want the whole pizza. Sometimes we just want like a slice of pizza. So how much crust would I need for one slice? So in geometry, you just found what fraction of the whole circle you needed, and then you multiplied it by the circumference. Okay, so for college pre-cal, it's the same concept, but it does involve more higher level thinking. If you look at, I'm going to explain this picture in a second. If you look at this diagram here, I don't know why that's cut off. It says radian measure. I want you to draw a box around this. Theta equals S over R. Now let me explain what these variables stand for. First of all, the theta stands for the angle, rotation, and this is the important part, it has to be in radians. Theta stands for the angle rotation, has to be in radians. S stands for the arc length. When we say arc length, we mean the distance traveled. So you need to associate the phrase arc length with the understanding that means distance traveled. And then the R is self-explanatory. It means radius. So the radian measure of a rotation is simply the ratio, fraction, of the distance it travels divided by the length of the radius. The angle in rotation absolutely has to be in radians. There's another must-have, and that is, I'm going to put an asterisk right here, S and R, the arc length and the radius, must be in the same unit of measurement. Of course, it is typed on your paper, but I didn't think you could see it. It says it right here. Meaning, if the arc length is in feet and the radius is in inches, you have a problem. You'd have to convert either one to the other or vice versa, but they need to be in the same unit of measurement, okay? All right, so now let's play around with this. So look right here. Let's copy theta equals S over R right here. We're gonna do some math here. Theta is understood to be over what? Anything's understood to be over a 1. Okay, so if I cross multiply the R over here, I would end up with R theta equals S, right? I'm just manipulating it right now. And if I wanted R by itself, I would divide by what? Theta. So R is S divided by theta. Right? You may find that that little fraction comes in handy. Notice that I'm not asking you to memorize that fraction. I got it by simply cross-multiplying from the one that you are supposed to have. I cross-multiplied the R over and then just divided the theta. And so I got the relationship if I needed to know the radius, and I had the arc length and the angle and rotation. I could just divide the two, and then I'd know the radius length. Let's draw a vertical line right here to kind of say, like, separate in a separate thought process. Looking at this picture, the smaller circle has a radius of 1. That's the unit circle, right? Then you have this larger circle where we're just going to say has a radius of R. If you look at the S sub 1 and then the S, that's describing the distance traveled from the initial side as it rotates and opens up, landing on the terminal side. So then over here with the larger circle, it would start on the initial side and then open up, rotate, land, and that S just describes how much it has traveled. Okay? Theta means the degrees or the radians, which in this case we have to be in radians, but I'm just reminding you radians is equivalent to degrees. Theta means the rotation itself. S means if I was to measure it in a linear format, how much did it travel, okay? There is a direct relationship between these two pictures. So S is proportional to the S sub 1 because they're the same concept, just like R is proportional to 1 because R is the radius of the bigger circle and 1 is the radius length of the unit circle, right? Now let's cross multiply this. I'm going to write a big OR here. If I multiply S1 to the right, and then I divide by R, y'all see what I'm doing there? But this is just a 1, right? So if I cross multiply the S1 to the right, and then I would divide the R to the left, I would end up with this over 1. Do you see how I switched that? And what is S over R? S over R is theta, right? Look right here, S over R. We just learned there's a new relationship, new formula in town. Theta is the ratio of S over R. Okay, so I'm going to write right here. Let's let S1 be theta, which gives us this really nice formula. We would have theta equals S over R, which we just learned. The purpose of what we just did, I realize some of you may be thinking, I hope this is not the practice questions. I wanted you to derive the formula to understand the relationship. The relationship of S over R comes from this diagram here in terms of the unit circle and then any other given circle. There is a proportion between their arc lengths and their radii. And if I set up the proportion and manipulate it, then I can get the relationship that the angle of rotation is simply S over R. Okay, so that's where this came about. Now, the practice questions are not asking you to explain or derive it. The practice questions are applying it. Okay, so now let's dive into how do I need to know to use this? Let's go to that, because I know that's what most of you are concerned with. Oh, yeah, absolutely. We have, do I have any like, Greek gods? Where's yours? Well, put it on real quick. Watch the cord right here. All right.
She doesn't.
Now, the question, how do I actually know what am I supposed to know how to do? Here's two practice problems. Let's copy the formula, theta equals S over R. Just remember S and R need to be in the same unit of measurement. Also remember, I'm putting an asterisk next to the theta. Remember, theta needs to be in radians, okay? All right. Find the measure of a rotation in radians when a point 2 meters from the center of rotation travels 4 meters. All right, y'all do that. All right, Bailey left. Read the question. When you read it and you realize I have no clue what it's asking, that means it's probably this formula right here. This is pretty much the only formula where I would say that everybody's like, what did you just ask? Read it once. Now go back and read it again and underline the important information. How many variables are in the formula? There's 3, right? If they're asking for 1, they have to give 2. Keep that in the back of your mind. I know word problems are not everybody's favorite, but there's 3 variables. They're going to ask for 1 of them, which means they're giving me 2 of them. I just have to know what are they giving me. Then I know what I'm trying to find, okay? All right, let's reread it. Find the measure of a rotation. That means find theta. So I'm making a note to myself, okay, measure of a rotation, that's theta, so that's my find, which means they're giving me what in here? Pointing to it. They're going to give you S, they're going to give you R. You just have to know how to read it and pull it out. Okay, find the measure of rotation in radians, we already know that. When a point 2 meters from the center, if it's 2 meters from the center, that's the radius, right? When a point 2 meters from the center, so that is the radius, it's 2m, make a note to yourself, that's the radius. Remember to copy the unit of measurement. From the center of rotation, travels 4m. Traveling 4m, that's S. They're telling you, almost imagine the arrow on the end of an angle as it's rotating. Imagine the arrow. And you're trying to determine in terms of meters, not degrees or radians, meters. How far did it travel? That's that measurement, and that's S. Okay, so we just read this. We just labeled it. Now I'm going to come over here and kind of sum it up, since this is our very first problem. We are finding theta. We know R is 2m. We know S is 4m. And now you just plug it in. So theta is S over R. S is 4, R is 2. They're the same unit of measurement, so we're okay here. We end up with 2. Now the question is, you need to know what you're talking about. You just found theta. Theta has to be in radians, so 2 what? It's 2 radians. Now let me give you a visual to understand what you just found. Because sometimes, I don't know about you, but for me, I do better to know, to have like a visual in mind. So if we have this circle, right? 2 radians. Do you remember what 1 radian was about? About 57. So 2 is going to land me just outside of the 90, right? Okay, so you have this rotation going just outside of 90. Okay, so you have your arrow to show where it lands. You're good. So we are finding the theta, right, with a radius of 2 when it travels 4m. So that's the visual of what you're finding there, okay? And it was just 4 divided by 2, which is 2. Now, but understanding the problems, now you can see why we just have 6 practice problems and then we're calling it a day, because it's very uncomfortable, you know, it's not something you're used to, it's not calling on prior knowledge really, so it's harder. So let's just keep practicing. We've got 5 more practice problems, and then hopefully by the 5th one, well, the 6th one, you'll know how to do this. So look at the next one. Find the length of an arc of a circle of radius 5 centimeters associated with an angle measure of pi over 3 radians. Okay, reread. Find the length of an arc. What letter does that represent? S. So you would say to yourself, okay, S is my question mark. We don't know. And I'd even make a note. I am finding S. Find S. That means they have to be giving me R and theta. Now I got to read it and be able to differentiate. You should not mess up theta, because theta is radians, or if it's in degrees, you have to convert it to radians. All right, of a circle with a radius of 5. Label it. There's your radius. It's 5 centimeters. Associated with an angle of pi over 3 radians, there's your theta. So I'm just going to kind of sum it up. So I'm finding S. I know R is 5. I know theta is pi over 3. Now, here's where you might want to think, well, never mind. So it's up to you. There's 2 ways to do this. I'll show you the 2 ways. The first way is just plug it in. So we've got theta equals S over R. Plug in what you know. I know theta is pi over 3. I don't know S. I know R is 5. Might be uncomfortable to know how to solve that. That's a proportion. You solve proportions by cross multiplying. But you really don't want to multiply the 3 to the right, because then you've got it next to S, and the goal is S to be by itself, right? The only thing in the way is the 5. It says divide 5, so you multiply by 5 over here. So you have 5 pi over 3, and that would go in your calculator. 5 pi divide 3. Be careful how you type that in your calculator. It's not 5 times pi divide 3 because then it's only going to divide the pi with 3. It's 5 pi divided by 3. So use the fraction shortcut or use parentheses so that you don't accidentally get the wrong value. Let me show you what I mean. I like the fraction shortcut because then I don't have to worry about parentheses and I can see exactly what I had on my paper. I can see it and confirm it. So it would be, we're going to go to the nearest tenth. It would be approximately 5.2 centimeters long. So S is approximately 5.2 centimeters. The alternative way, I'm drawing a line. Actually, I'll draw two to kind of separate. The alternative way is starting back with, and if you don't like this, don't write it, starting back with the original formula. If you're not finding theta, if you're finding one of these over here, take the original formula and manipulate it so that the letter you are finding is by itself. So if I'm finding S, I can cross multiply the R over there, and then I can just plug in the radius is 5, theta is pi over 3. You still end up with the same thing. It's just you're doing the cross multiplying in the formula, not with the numbers. But you still end up with the same thing. Doesn't matter which way you go. Okay. All right, that's 2 problems down. 4 more to go. So let's go to the next one. Go ahead and start it. Let's see if you can identify what variable they give you and which one you're trying to find. Actually, this one is just like example 7, so you try it. Let's see if you get it right. So if you still are struggling with this, it's okay. It's only the 3rd example. College pre-calc, give yourself a break. I am going to copy the formula because I'm on a different slide. We have theta equals S over R. Just remember theta needs to be in radians. Okay, find the measure of rotation in radians means find what? What variable does that mean I'm finding? Theta. So I'm going to make a note, theta equals question mark, meaning I don't know it. Find the measure of rotation in radians. When a point, 0.25 miles from the center, that's what? The radius. So R equals 0.25 miles. I'm going to put MI so I don't confuse it with meters. From the center of rotation travels 6 miles. That's what? S. All right, plug it in. Miles, we're good. We're finding, theta. So theta equals S over R. We've got 6 over 0.25. Did you get 24? Radians? Yep. Wondering why it's 24, that was 6 divided by 1/4. You don't divide fractions, you keep, change, flip it, so it's 6 times 4. Okay, let's try one now where it's not in the same unit of measurement. Or not, I'm sorry, it's not straightforward. There's something in there that you're going to have to tweak. In a circle with a 20-foot diameter, an arc 4 foot long subtends an angle of how many radians? Okay, what's the trick here? We're giving you the diameter. We don't want the diameter, we want the radius. So don't run with that 20 because you're going to get it wrong. This is the diameter in feet. I need the radius. Remember that relationship from geometry. If you ever forget, diameter is the bigger word, so it's the bigger segment. Radius is the smaller one. It's half the diameter. Okay, so now we're okay. And honestly, I don't know about y'all, but I tend to, on my paper, like if I have a number that I have to later, I have to adjust to get the real number I need, I go back in and I mark out the old one so that I don't accidentally use it. An arc 4 foot long subtends is a way of saying you have this arc and they're telling you that it measures 4 feet long. They're telling you S. It subtends meaning it's spanning, okay? So they're giving you S right here. They're saying that S is 4 feet. Of an angle of how many radians? This means I'm finding what? Theta. We'll put a question mark. Then, of course, it says, what about if it were in degrees? So this is us refreshing you on how to convert. Get your answer in radians, then convert it to degrees. Get 0.4 radians. Okay, refresher from yesterday. How do you convert between radians and degrees? Which one did I tell you needs to be on top? The one you want, the goal, right? If I want it in degrees, I need the, what on top? The 180 on top. Okay, so I need 0.4 radians to be in degrees. Remember from yesterday, if there is no pi right here with the radians, it means that you're going to have to actually type that in the calculator because the pi got multiplied into the 0.4. We got to divide it out so we can see what the radians are. So you go to your calculator and type 0.4 times alpha y equals 180 over pi. 22.9 degrees. Now, let's wrap your mind around what you just found. Go back to, remember I said a radian's the wet spaghetti noodle, right? The cooked one. Okay, and we said that 1 radian is about 57 degrees. Yep. So 1 radian's about 57. So almost half a radian should be almost half of 57. So check your answer as you do this. It should all stay proportional. All right. I'm looking at the next one. Here we go. So read it. Underline the important info. Find what they're telling you, like tell me what they're asking you to find. Okay, find the length of an arc. Oh, that might be cookies. Okay, find the length of an arc. That means what letter? The length of the arc is S. So they're saying S is what? Of a circle with radius 8. You should feel confident to get R right every time. You should feel confident to get theta right every time because theta is the only one in radians or talking about rotation, okay? S is the other linear unit of measurement, and it's referring to the distance that it actually traveled. Okay, so R is 8 centimeters, associated with an angle of pi over 2 radians. So we've got theta, we've got R, we need S. Two ways to do it. One is going from the formula that we've been doing and just plug it in. You want S by itself, so you'll have to multiply that R over. Or if that makes you uncomfortable, I'm going to go up here at the top. We have theta equals S over R. This is the one you're supposed to have memorized, right? I'm going to write or, cross multiply the R over. There's an alternative formula, right? Which would be helpful here because I need S. So I can pull S equals R times theta, and now I can just multiply them. You don't have to go that way, but it's more intuitive, I guess you could say. Okay, R is 8. Theta is pi over 2. You can actually probably simplify that in your head. So that's going to be 8 pi divided by 2, which is 4 pi. You do need to go to your calculator and get the decimal, though, because we are talking about unit of measurement, like in terms of a linear. So you get about 12.6. Did you get that? So 12.6 centimeters. All right, try the last one. I'm going to go ahead and tell you the answer is 165. Let's see if you can get there. Get to 165. So, what's your take? I know it's not your favorite, but what it's not that bad, right? It's just uncomfortable because nobody walks around saying, I wonder what the angular rotation, Yeah.